Good evening. Thanks for coming. If you're here to learn about Python, then you're in the right room. Thanks a lot. You have a really good attendance this week. My name's Jeff. I'm kind of the MC or host tonight, and we're going to hear a talk by Dan Bikle, and we'll probably start that around 7:30. So this is our agenda tonight. A few intro things about what this BayPiggies group is about. Then we'll have if anyone has any pre-talk announcements, anything they want to get in before the talk starts. We'll have the talk, then we'll have some thank yous, and post-talk announcements, which would be things like, this group, if you want to talk about so-and-so, meet me over here in this corner, that kind of thing. And then finally, if people want to offer a job or want to ask for a job, they can do it at the end. They can also do it early if they want to as well. Any time for jobs. Great. So let's see. I guess we'll get started. So who is BayPiggies? So it stands for the Bay Area Python Interest Group. The pig is not about eating pizza. It's about Python Interest Group. And so it's actually much older than Meetup.com because the first meeting was held in July of 1999. According to the graybeards that told me this, and the first speaker was Guido, the inventor of Python. So I think he's talked to this group several times. Anyway, and so it's mainly organized through a mailing list, which I'll have. It's the BayPiggies.python.org, and I have that info on the next page. And it's using this really old Python program called GNU Mailman, which, anyway, it says like Python powered on it, and back in the mid 90s, that was a big deal because everything was either Perl or C back then. Anyway, so it's been the organizing has happened through the mailing list, and kind of as long as I've known it about this group, the meetups are always on the fourth Thursday of the month, and over time we've had different companies host us. And for the last few years, it's been Meetup, and, they're doing a great job, and free food and great facilities and everything. So it's really great for us. And we usually take November and December off. And I think there's some kind of Bay Area Python party that the San Francisco Python people are organizing every year now, or they're trying to make it yearly. And everyone's welcome. There's no membership fee or anything. So welcome to BayPiggies. So this is, any questions? Okay, anyway, so our main mailing list is there. We have a website. There's a whole lot there, but you can always find out about the latest meeting, and you can post jobs or look for jobs on the website. And if you go to the lower left-hand corner, it has the link on how you join the mailing list. And so we also obviously have the Meetup group, which is, I think, how a lot of people found out about this, and so we that's sort of a mirror of whatever we have on the website, so we try to keep that updated. Okay, so does anyone have any pre-talk announcements or anything they would like to announce? Vicky? Or
I'm Vicky Toot, and we are trying to get PyLadies in the South Bay or Peninsula. And so meet after the talk, and we'll try to get even more organized. Thank you.
Thanks, Vicky. Anything else? Okay, and I guess we're ready to start with Dan, so I'd like to introduce Dan Bikle. He's been very gracious to come up and talk. Yeah, give him a hand of applause. And he's going to tell you about using the stock market to learn Python.
I have a mic. Can you hear me? Oh, good. Okay. So we're going to switch over. I had this working earlier, so we'll find out if it'll still work. If it doesn't, I'll reboot my laptop. So I tried giving this talk to myself earlier today, and I got about a third of the way through it. So I don't think we'll get through the whole thing, but I think you'll find out soon enough whether you like it. And what that means maybe is we'll have maybe some people leaving a little early. We'll see. Wow, this is a good sign. So what I'll do is I'll just kind of use this page here to get us started. This is the Meetup page. And so we'll be talking about plain Python and NumPy. And, well, one question I kind of had was, is it NumPy or is it Numpy? I prefer NumPy. And there's Pandas, scikit-learn. Then we have matplotlib. There's a typo there. It should all be one word. And that's used for visualization. Heroku. Heroku is a service that you can use to run software on the web. And it runs Python, so that's a good thing. So what I have here are 4 different links, which kind of give us a little bit of perspective. The first 2 are GitHub links to the software that I'll talk about tonight. The next one is a website that has some advertising. And then the 4th link is sort of what I hope to use is the presentation. We'll see how that goes. So the first link is here. I tabbed it all up. So this is a repository called PySpy. Oh, by the way, if anyone has a question, feel free to go to that microphone over there and just wave at me, and we'll take questions that way. And I think that's a good thing if you can ask questions, because generally it's if I only do speaking, then you might not learn as much as if you actually get in front of 300 people and ask a question. Okay, so here's the second repository. This is software which I use to actually run on Heroku. Who's familiar with Heroku? Okay, so a few of you. Yeah, basically it's this service that you can go to and deploy a website for $0. So it's a pretty good deal. So what I'll do is I'll use this web page here as sort of my talk. And as you can see, it's kind of got a lot of stuff in it. So now you can see why maybe we might not get through the whole thing. When I first did the talk, I was sort of intending to turn it into a class where people would sit at tables and bring their laptops and kind of hang out and do stuff. And we're not doing that here, so but I still think it could work. What I'll talk about first is this link here called Python presoaked questions up here on the top. So typically when I learn something new software-wise, there's basically 2 ways I do it. One is I'll put together a long list of questions as I'm going through the material, and I'll try and write down answers to the questions. So this sort of follows that example. So I'll right-click on that and open it into another tab. And so what I'm presenting to you is, I call this the take-home test. Okay, so here's a bunch of questions that I might answer, but perhaps better, this talk would kind of serve as sort of as an introduction to the questions to give you a little bit more perspective, so that when you see a particular question, you might not have so many questions about it. So it just goes on and on and on forever. So that's the take-home test. Another way that I learn besides questions is I can remember when I first learned Ruby on Rails. They had this thing called the skateboard book. And the idea behind the skateboard book was that they would give you an example of an application that you would need to build, and then that would drive the learning, okay? So there's different words for it. What I'll do is I'll call it sort of use case-based learning. So here's the use case that we'll use tonight to sort of drive the learning of something that a beginner who's being introduced to Python would want to deal with. Okay, so the use case is something that I actually deal with myself every day. Well, every weekday. Usually late in my lunch hour, I go and look at the stock market. And basically I want to know what will happen over the next day. and I run Python software to help me sort of make that prediction. Okay, so instead of Ted the trader, there's actually a trader out there called Dan who does this. And I run Python software. And usually about 12:55 I run it, and I have 5 minutes to act on that prediction. And typically, the predictions tend to sort of stay the same. For example, they'll tend to stay bullish, or sometimes they'll tend to stay bearish. Well, the term bullish or bearish, do people know what that means? Okay, so I guess not everyone knows bullish. Okay, a bullish prediction is a prediction that the stock market will go up. And a bearish prediction is a prediction that the stock market will go down. Okay? So I like to use software to make these predictions and then act on them. And fortunately in California, you can do this during your lunch hour, so well, that's a good thing. So you look busy the rest of the time at work. So that's use case discussion. Next, I'll talk a little bit about Linux. When I write software for clients, for example, typically what I want to do is find out where will the software run. And usually, within I'd say the last 10 years or so, it's usually on a server in a data center or on, quote, the cloud. And usually that means Linux in my book. So there's that. I go into sort of a discussion here about what that means. For the beginner, what it means is if you're going to do software development with Python, try and find out what the customer wants. And if the customer wants Linux, then you should start running Linux right away and do your development in Linux rather than trying to run Python on a Mac and then hope that it will work on Linux. So what this is some Linux syntax that I typically run after I set up my Linux environment. Since you're all beginners, or at least I hope you're beginners, let's go through this kind of slow, okay? So there's this command called sudo. Does anyone want me to talk about sudo? Okay, so we've got a few. Sudo is this way to get into a privileged mode inside of Linux, okay? And you might bump into it on the Mac. So if you're running a Mac, it might be sort of familiar. Next, we have a command called aptget. Okay, so this is particular to a specific flavor of Linux called Ubuntu. Okay, so it's a way to go and get enhancements for your operating system. And the first command I'm running here is aptget update. So what that does is that goes out to the internet and sort of gets information about servers out there that have the software that you want. Okay, it doesn't actually update anything on your laptop yet. It's more like updating an index. Okay, the next command, sudo aptget upgrade, that actually goes out to the internet and gets the latest and greatest software that you should have running on your Linux box. Okay, after that, typically what I do to set up my Linux environment is run this stuff here. And this goes out and enhances the Linux environment. So does anyone see Python in this list? The answer is no. So it begs an obvious question, should I use aptget to install Python in my Linux environment? And in my opinion, the answer is no. So let me go into that a little bit. When you install Linux, originally, if you have a clean installation, it will come with Python in there, and that's something that I personally want to stay away from. I've seen evidence that Linux kind of depends on it, so I don't want to. I assume it's pristine, and I'll stay away from it. So I install Python in a different way, and we'll talk about that here in a few minutes. What these things do, here's probably the most important one, is a package called Build Essential. That is basically something that's important for compiling and linking software, usually C software. This one is important. This is called Git-K. That's for, who's worked with Git? Okay, so most people know what Git is. If you install Linux, it usually doesn't come with Git, so you need to install it. And I like to install a thing called Git-K, which is sort of a graphical user interface to Git. And if I install it, it's smart enough to go and also install Git. One thing that I would leave out if I were in a hurry is Chromium browser, because it's kind of big. Generally, if you install Linux, it comes with a browser, Firefox. Okay, so after I install all of that, I've got a nice, wonderful Linux server that's good for development. For this particular use case where we're talking about the stock market, the next thing I want to install is software called talib. Okay, TA is an acronym for technical analysis. And it's C software that it allows you to work with time series data and do things like find slope of a moving average, Bollinger Bands, different things that are sort of interesting to someone who does, quote, technical analysis on the stock market. Okay, so it turns out to install that, you have to get it from this old place called SourceForge. I looked for it on GitHub and I couldn't actually, well, actually I found several. And I ended up going over to SourceForge for it because I trusted it a little bit more. So if you look at this, this is sort of an old style installation of software. Basically what I'm doing is I'm pulling down a tar file, I'm unpacking it, I run this shell command called configure, and then I run a make and then a make install. So if you're a C programmer, this will kind of make sense to you. If you're not, this is just sort of like following a recipe to make cookies. It's just what you need to do. After I install that, now I install Python. And this is probably the part that might be the most important thing that you walk away with if you're a beginner. And that is that, in my opinion, if you want to run Python on your laptop, you should use Anaconda. Anaconda is, if you go to Google and you type in Anaconda Python, sometimes you'll find these different images of this giant snake in the Amazon rainforest that's like eating an alligator. It's probably photoshopped, but the idea is that you've got this Python distribution that's really, really big, and it's got a lot of stuff in it, and it saves you a lot of work. So I've kind of fallen in love with Anaconda Python. It's got one thing about it, though, that's a little bit strange, and that is that it doesn't play well with the utility in Python that I like to use. And that utility is pip. Okay, pip is a way to go and pull external packages into your Python distribution and install them. Okay, Anaconda uses a utility called Conda. Okay, so if you look at this presentation here, right in the middle of the page, what do I do with talib? I do a pip install talib. So that's kind of incongruous because, okay, I'm supposed to use Conda to install stuff into Anaconda, but here I'm using pip. So you might ask, well, why is Dan using pip to install talib in Anaconda? And the answer is, well, it's the only thing that would work. Okay, I tried to use Conda and it didn't work. So hopefully that'll answer any question about why I'm using pip with Anaconda. It's kind of ugly, but I decided to go ahead and do it because it worked. Okay, after I install talib, then this Python command should work. Well, let's talk a little bit about pip. Like I said earlier, pip is this thing that goes out to the internet, and we saw something similar to it when we were working with Linux. Okay, Linux has this thing called aptget, where it goes out to the internet and gets software. Well, Python has something similar called pip. Okay, and then Anaconda has something similar called Conda. Okay, and then other languages have, like for example, Node.js has npm, and Ruby has gems. So pip is something that you should sort of be familiar with. It goes out to the internet and pulls stuff into your distribution. Okay, so after we install that, this should work. Let's talk a little bit about the -C option in Python. What that does is it allows you to run Python inside of your shell in a way that it's sort of friendly with your shell. Okay, so what that means is typically when I run Python, I'll put all my Python syntax inside of a Python file, a .py file, and then I'll type in python dan.py, and it will run. But it turns out if you're a shell programmer, you can use -C to make your shell programs a little bit beefier. It'll make it a little bit more complex, but on the other hand, Python has the ability to do complex things compared to shell. So that's something to keep in mind if you want to write shell scripts that are sort of complicated, is you could actually use Python with the -C option. Let's talk a little bit about this command called import. Okay, import ties into this idea of pip and Conda. Okay, so if I use pip or I use Conda to go out to the internet to get some software and bring it into my distribution, when can I use it? How do I use it? Well, what I need to do is I need to put a token inside my Python script that starts with import. Okay, and that tells my script, oh, okay, he wants to use this thing inside the distribution. I'll do that. And I'm sure there's a good reason for this. Perhaps the people who wrote Python, they probably didn't want to create something where you could go and pull in a lot of packages all at once. They wanted to make an environment so that you could sort of selectively pull in stuff from your Python environment into your script. So in this example, I'm pulling in two things. I'm pulling in Numpy, which we'll talk about later, and then talib, which I had just installed with pip. Okay, now let's talk a little bit about this application that I'm building. Okay, so this application is going to generate a prediction once a day around 1 o'clock. It's actually got two modes. It's got what I call noon mode, where it runs about 12:50. But I also wrote a mode so that I can run it at night. Okay, that's described down here. The one that runs at 12:50, what I personally do is I run it manually. I go and I log into my laptop and I run it. But one thing I could do is I could automate it. Okay, and the way you automate things in Linux is with a utility called cron. Okay, since this is not the Linux Meetup, I'll just say that if you want to automate something in Linux, use cron. Okay, and then we'll stop there. I won't show you how that works. But one thing I will say is that cron will call Python at a time that you specify, and the granularity that you have is once a minute. Cron wakes up once a minute and says, do you have any work for me right now? So that's how that works. When I run this at night, for example, if I were at a meetup and I wanted to show you how this software works, I have a script called night.bash, which is, this is what the command line looks like. And then if you wanted to actually see the script, it would be over here in this tab in this GitHub repository in a folder called bin. Okay, so this is what I would run at night to sort of demo this thing. So the first thing it does is it sets up some environment variables, and then it goes and gets some data, and then it runs 1, 2, 3, 4, 5, 6 Python scripts. So since this is the Python meetup, we should probably drill down into these Python scripts and see how long we can get people to stay awake. So this is what it looks like on your screen when you run it. Here's me running the actual command. It goes and hits Yahoo, gets some data. The first interesting thing to come out of this is this syntax here. Okay, if you showed this syntax to some people in this room, or I'll highlight it again, we might have some data scientists in here, and they would say, oh, that looks like output from a thing called a binary classifier. So a binary classifier is sort of this data science machine learning concept tied to predicting things. And if you look at the weather report every day, you'll see an example of not a binary classifier, but a classifier. The way the weather classifier works is, okay, I predict it will be cloudy, or I predict it will be sunny, or I predict it will be rainy, or it'll have different classifications of weather. So that's an example of classification. Then an example of binary classification is, oh, it's either going to be sunny or it's going to be cloudy. Okay, so this is an example of binary classification. And basically what it is it's telling you about the predictions of the stock market, whether they're good, how good they are for up or down. Okay, so there's two classes that I'm trying to predict. Will the stock market go up or will it go down? In my opinion, if I can accurately make those predictions, it could be lucrative. Okay, I don't need to get any more exact than that. I don't need to do, for example, regression. So in machine learning, you have this idea of regression. So an example of regression in using weather data is if you look at the weather report, they'll give you the classification. They'll say it's cloudy or sunny or whatever, but also they'll give you a number, which is the high for the day or the low. Okay, so that's an example of regression. They'll actually give you a variable number. Okay, and that's something that I could do with the stock market, but I figure that the stock market is so random and hard to predict it would be a waste of time. I would be happy just with binary classification. So if you look at this binary classification output, we had 63 true positives and 61 false positives. Okay, so true means that it's working, and false means that it's failing. Okay, positive is a prediction that it's going to go up. Okay, negative is a prediction that it will go down. Okay, so looking at this output, I can see that it did much better at predicting the negatives than predicting the positives. Okay, and then what I can do with these numbers is I can do arithmetic on them, and I can get a measurement called accuracy. So basically the way you do accuracy is you take the number of positives and you divide it by the total number of observations. And if it's way above 50%, you win. If it's below 50%, there's a problem and you probably shouldn't be using these predictions. I can see that for the positive predictions, I'm pretty close to 50%. So I'm kind of sensing that it's not doing a very good job with the positive predictions. It is doing a pretty good job, though, with the negative predictions. I'm 56% accurate with the negative predictions. And in my mind, that gives me hope because the stock market really does have a lot of randomness in it. So that's true positives, true negatives, false positives, false negatives, and accuracy. The next measurement, which is important, is what I call effectiveness. Okay? Effectiveness is I go and I get all of my positive predictions and I average the result. Okay? And this is important when dealing with the stock market because the distribution of one-day gains in the stock market is not normal. It's a strange distribution. I'll show you what it looks like if I still have it here. It basically looks a little bit like a spike. So this is a distribution of one-day gains on the S&P 500. So what I could do with this distribution is I could calculate an average, and I could calculate a standard deviation, and that would give me a thing called a Gaussian or a normal distribution. And I could overlay that on top of this. And the normal distribution would be fatter than this. This has a sharp spike in the middle. And then the normal distribution would fall off pretty rapidly. Okay, whereas this doesn't. This is spiky in the middle, and then it's got long tails. Okay, so going back to this discussion about effectiveness. Effectiveness helps me understand how well my machine learning gizmo is working on the outliers. It's important that I get the outliers right. And the reason why is, well, it's the stock market. If I can accurately predict the outliers, that's important. And there are some large, like for example, if you look at this data, the largest minimum outlier is minus 20%. That happened in 1987. And this particular visualization only goes out to minus 6. So the largest outlier, negative outlier, is like 40 standard deviations away from the mean. It's very important that I can accurately predict that, or effectively predict it. Okay, so that's what this report is it's sort of giving you information about how this Python software is behaving. So let's keep scrolling down here. This talks a little bit how this thing behaves at noon. The main difference between when I run it at noon and when I run it at night is when I run it at noon, I can't get the data directly from the Yahoo CSV file. I have to go to the web and scrape it. So I use Python to do that. So if you're a beginner and you want to know how to use Python to go to the web and scrape data off the web, this would be a good place to come and look for clues on how to do that, because I show how to do that. Okay, so let's talk a little bit about the machine learning ideas and technology that I use to make these predictions. When I first started predicting the stock market, I went to Google and tried to find out basically how people made decisions. And what I found pretty quickly is they make decisions from things with names like simple moving average, money flow index, Bollinger Band, stochastic calculator. And what I found was when I would go and wander around the internet, I would find a lot of hand waving about what these different things mean. In my opinion, this stuff might be useful, but not in the hands of someone who wants to describe them. It's more something that I should feed to a machine, and the machine should use this to make the decisions. Okay? So here's an example of some intuition that you could use to build the machine. When the price is below the 5-day moving average, I should be bullish. Okay, well, is that true or is that false? Well, the answer is I don't know. Okay, so what I should do is I should go and get the price and the 5-day moving average and collect those observations and feed them into a data structure that I can feed to a machine. Okay, so how do we write Python to do that? So the first thing I would do is I would kind of visualize what that would look like. So I would think in terms of CSV. So the first column would be date. Okay, then I would have the price. And then I would have the calculation here. Okay, and what this calculation is the price over the 5-day simple moving average. Okay, so oh yeah, we've got a question. Thank you. Yeah, well, just scream.
So you mentioned the S&P 500. I'm kind of wondering, are you talking about the price of that index? Everything based on that, or do you look at a stock in there? What exactly? What stock market are we in?
Okay, so the question is, what stock market are we in? The prices that go into this machine are S&P 500 prices that I get from Yahoo. And let's take a look at what that URL is. Well, here's a clue right here. This is a scrape of the Yahoo page. Okay, and here, so if you go into Google and you type in GSPC, right there, that would send you to Yahoo or Google. And you would see a list of prices. So the answer is I'm getting S&P 500 index prices from Yahoo, and the symbol is GSPC, and right now I think it's pretty close to 2,000. Okay, so this is kind of what the data looks like when you pull it into Python. I start with an array. It's a nested array. Well, first of all, I'll assume you're all beginners, so let's kind of go slow here. And the first question is, oh, you got to go to the microphone. So the first question is, in Python, how do I create a comment? And the answer is, well, I put a hash in front, okay, if you're a beginner. Okay, the next question is, well, we've seen import. Let's review what import is. Import is a way of declaring in my script that I want to use Python software that's out in my distribution. So in the Anaconda distribution, somewhere in there should be a package called statistics. Question?
Is the data like cumulative data, or is it like just on the previous day?
Okay, is the data cumulative data, or is it just based on the previous day? Every time I run this thing, it goes and gets whatever Yahoo gives me. And I don't try and keep track of what I did before. So from that standpoint, no, it is not cumulative. Does that answer your question?
Well, is it then you just use the previous day's data to guess the next day? Or do you...
Oh, okay, okay. So now, okay, this is sort of a subtle thing. How do I guess the question is, how are you making your decisions? Like, okay, I use these, I'm headed there, okay?
Okay.
Soon, okay? The short answer is I use features, and I build the features from previous day prices. Okay. And the most important feature is what I call the previous day delta. Okay. I found that the previous day delta is the one that seems to have the most impact. Okay? So back to beginner land. So what this does is this imports a package called statistics. And then I create a nested array. So I have arrays inside of arrays. Okay, this is important syntax right here. This is an example of a Python thing that everyone should know. It's called a comprehension. So you should know what a comprehension is. A comprehension is syntax that allows you to take a Python for loop, put it inside of a little package, and when it's in there, it will loop, and then it'll kind of emit things out, and you collect these things that it emits out, and it kind of sends them off to the left-hand side. So on the left-hand side of this comprehension, we have a thing called D_CP_L. And everything inside this loop goes inside of here. Okay? So you might say, well, what's this thing here? Well, that thing here was just declared right here. Okay, so the question is, what does this comprehension do? And if you look at the comments, it tells you. I reverse the order of the data. So the way I reverse the order of the data is I create a comprehension where I start with this. I send it to a method or a function called reversed. Okay, and then whatever comes out of reversed goes into this variable called row, and then this thing here collects them. Now, one naming convention I use when I work with beginners is this is a bad habit, so I'll just start right off and say this is a bad habit, but it's still kind of useful. Oftentimes, when I create a variable in Python, I'll put a suffix on the end, on the right-hand side, that tells me what that thing is, what kind of data type it is. Some people will find that very objectionable. Okay, I actually find it kind of convenient, so that's why I do it. Okay, so if you look at this, right here we have an _L on the end. That is telling me that this thing is a what? It's a list. Okay. I broke the rule right there. This is a typo. This should be CP underscore L, but I called it CP underscore A because originally when I was tinkering around with this, it was an array, but now it's a list. So this, I'm kind of breaking my own rule here. So here's another comprehension. What I do is I take D underscore CPL and I put it in here. I pull a row out of it. And what does this do? It goes and gets, so we need to talk a little bit how to dig inside of a list. Okay, so if you're a beginner, the way you dig inside of a list is you use these square bracket things. Okay, so here's an example of a list right here. How many members are in this list that I've just highlighted? 2. Okay, so row bracket 1, which would it be the date or would it be the price? Would be the price. Okay. So what I do is I collect all the prices via this expression here and I put them into this. So what should this thing be when this line runs? It should be a list of prices. Okay. Then what I do is, okay, so here's some syntax that might be useful to some people. If you ever go to a job interview and they ask you to write a for loop where they say, okay, here's a list of numbers. We want you to create a for loop which calculates a moving average on that list. Well, this is what you would do. And this would be a moving average where, how far back do I go to compute the moving average? The answer is 5. Okay. The next, so what I do is I start off, I set this thing equal to, so it's empty, and then you can see down here it's getting filled with stuff. Let's walk through this real slow. It's 8:07. Jeff, how far should I go before, I'm about like 1/10 of the way into the presentation. Should we go to 8:30 and then declare nap break or? Okay. Yeah, okay, so at 8:30 we're going to have a nap break, okay? Okay, so let's talk about this thing here, range. Okay, so range is a function that allows you to create what? A range of numbers, okay? So if you work with a language like JavaScript, if you have a for loop, basically what you need to do is you go something like for I equals 0, I less than 17, I plus plus, and then you have some syntax. And then it goes through this loop several times. In Python, you don't do that. In Python, you have this thing called a range. And the range, there's various ways to control it. Like I could have range 9, and it would give me a range that's 9 wide, and then I could use that to drive my for loop. This range has 2 arguments. It has 1, and then to the right, it has 1 plus length of CPA. Okay, so this doesn't actually start counting at 0. It starts counting at 1. Okay, what I do in here, so that's what range does, and I'd say probably the most important thing you need to remember as a beginner is this colon on the end. I've made this mistake so many times when writing for loops, is forgetting to put the colon on the end of the for loop. Okay, so we have that. Here's this variable called Rn. The first thing I do is subtract 5 from it. That goes into Rn0. Then I play this little dance where if I'm early on in the range, I have to be careful. Okay, once I go past 5, then creating the moving average is a little bit easier. Okay, but at the beginning of the range, creating a moving average is kind of tricky because I don't have enough data yet. Okay, so that's what's going on there. Then what I do is, this is where my average is collected in this variable called average this. Okay, what is this syntax here? It is a slice. Okay, so the way this works is, again, we're using square brackets. So square brackets seem to be showing up a lot. They show up in my arrays, they show up in my comprehension, and then they show up in this thing called a slice. So it's kind of like a slice of pizza. What you do is you have a beginning of the slice of pizza and you have an ending of the slice of pizza. In the beginning is this variable called rn0, which is set here or here, depending. If it's too small, it's going to start at 0. Once you're far enough along in, then it will start at something greater than 0. And then Rn is, where is Rn? Oh yeah, it's in range. Okay. So anyway, long story short, this is how you make a moving average from a list. Okay. So what do I want to do with this moving average? Going back to the original spec, I want to put it into a calculation where the calculation uses the moving average and the current price. So let's go back and take a look at where I talk about that. Create a list of observations of current price over 5-day moving average. So here I have the moving average. Here's a bunch of syntax that really doesn't do anything. It's just when I run this through my debugger, I like to check certain things, and the way I check things are with a double equal sign. For example, I want to make sure that the length of this moving average is the same length as the current price list, and so on. Okay. So all of this stuff should be true, otherwise I've got some kind of syntax error in my script. Okay, and then what I do is I actually do the calculation here where I take the current price and I divide it by the moving average and I put it inside of this. And that this demonstrates how to create a current price divided by a 5-day moving average. Okay? And then this is what the output looks like. So the first one, the current price divided by the moving average is 1. And then it looks like it's starting to go below 1. And so on. Okay, so that was an example of feature creation using just plain ordinary Python. Okay? And the feature is current price divided by 5-day moving average. Okay. Do you think that's a good feature for machine learning? Do we have any technical analysis traders in here? I think it's okay. I won't go into a description of why, but I will say that if the current price divided by the 5-day moving average gets really strange, that currently means something. Okay, it might mean that the market's going to move one way or the other. Or on the other hand, if it's close to 1, that means the market's kind of quiet. And typically, in my opinion, when the market is quiet, it's unpredictable. On the other hand, when it tends to get stretched, like if it goes down hard or if it goes up hard, in my opinion, that means it's moving towards a more predictable state. And one way I detect this is I take the current price and divide it by the 5-day moving average. Okay, feature creation with Numpy. So Numpy is syntax that you can run inside of Python that I'd say its most beautiful feature is it allows you to do this thing called array arithmetic. Okay, so array arithmetic is you have array 1 and you have array 2 and you want to add them together. Well, if they weren't arrays, if they were just lists, what would happen is Python would say, oh, you don't want to add them together, you want to concatenate them. I say, no, no, no. What I really want to do is I want to take each element in array 1 and add it to each element in array 2 and then do that instead. So that's an example of array arithmetic, and that's something that Numpy is good for. Okay, so here we're going to use Numpy to generate some features. And let's see here if there's anything in here that's sort of interesting. Okay, we saw this already. This is, well, okay, let's take a look at this first. Okay, when you see this syntax a lot, import NumPy as NP. Okay, what this means is I can use this token NP as a way to signal that I'm going to call a NumPy function. So that's useful. Next, what I do is I use just plain ordinary Python to create some lists. The naming convention here is CP lag, which means it's the current price lagged by 1. Okay. Then I have another list here, the current price lagged by 2. So I go 1, 2, 4, and then 8. Okay. What I'm doing here is I'm moving towards a calculation. In the calculation, this is where I use the NP to transform these lists into a Numpy array. And here I actually do follow my advice. I put an underscore A on the end of the variable names so that when I see that variable, you got to go to the microphone. When you see the array, well, I don't know, you can tell me and then I'll yell.
Can you go a bit more into what do you mean by lagging prices?
Okay, question, can you go into more about lagging the prices? Let's take a look at the data. Okay, so let's look at December the 2nd. Okay, the price on December the 2nd was $2,079.51. Okay, the lagging price was what? $21.02. Okay, let's take a look at the 10th. Okay, here the price was $2052.22. Okay, if you go back 8, then that would be this one here. Okay, so 1, 2, 3, 4, 5. Well, let's say it's this one here. So the lagging price is, in my opinion, the most important lagging price is the one that's the closest. That seems to have the most effect. But, since I've got a computer, I might as well use the other ones too. Does that answer your question? Okay. Okay, so here's an example of how I create the Numpy arrays. Okay, and then this is an example of the array arithmetic. Okay, so the array arithmetic is I have this array, I subtract that array from it, then I divide it by this array, then I multiply it by 100. So what these are and then I give them a name that kind of tells me what's in there. That's a percent lag. Okay, so I have percent lag 1, 2, 4, and 8. And in my opinion, this stuff, this data, I can learn from. Okay, so for example, if I used SQL to go and find all of the really away from the mean percent lag ones, I could collect that into an SQL statement and then find the corresponding average of the percent lead, and I would see that there is a relationship between percent lag 1 and percent lead. And in my mind, that's a good thing, because then it might be lucrative. And not only is it good, but I could then feed it to a machine, and it could also make decisions. Okay. Early on, we talked about installing talib, which was that C software. Talib gives me many things besides percent lag. It gives me, in this particular example, it gives me a calculation called a Bollinger Band. Has anyone ever heard of a Bollinger Band? Okay, a Bollinger Band is a data visualization that tells you how volatile prices have been recently. Okay, so if you look at if you go to Google and you type in Bollinger Bands, what you'll see is a time series. And as it marches along, you'll see 3 bands. There will be an upper band, and then in the middle is either a simple moving average or the real price, and then a lower band. And when the stock market gets active, the bands spread apart. Okay, and when the stock market is quiet, they move closer together. Okay, so previously, we had a calculation where I took the current price and I divided it by the 5-day moving average. Well, I'm thinking, if I have this band and the price is up near the band, maybe that means something. So what I do is I take the current price and I do a calculation where I take the current price and do something with the band. So the obvious things would be either take the current price and divide it by the band, or the band divided by the price. Let's see how we do that. Or let's see if I do that. Here I'm getting into a discussion about pandas. Okay, here we go. So in the Python script, I import NumPy. This is the important part for this demo. Import talib. Okay, once I import talib, that means I can use it right here. Okay, so talib has a function I can call called bbands. It's all uppercase. And the first thing it takes is the current price. Okay, and then a time period. I got to tell it how far it needs to look back and forth for these bands. Okay, then I need to tell it, well, okay, I need to tell it something about the bands. Okay, how far should the bands be? And it uses standard deviation. So basically what it wants to know is how many, here I'm using 2 standard deviations for both the upper and the lower band. Okay, so some people might think if the current price is near 2 standard deviations from recent activity, that might mean something. And you can use Bollinger Bands to tell you if that's true. Okay, and then what comes out of this are 3 variables, the upper band, the middle band, and the lower band. And what I do with those bands is I divide them by the current price. Well, the first one I divide by the current price, the middle one I divide by the current price, and then the lower one, I put the current price on top and do that. And that's an example of creating features from talib and Bollinger Bands. And it turns out talib has like 40 different calculations you can do. I just picked Bollinger Bands because they're kind of easy to visualize. Okay, we got 8 minutes. Let's get into Pandas. Pandas is something that you as a beginner might want to learn about. It's different than NumPy from the standpoint that I think of Pandas as something that's a little bit more useful for someone who understands spreadsheets. Okay, so if you're used to dealing with spreadsheets, what you have is this concept of columns across the top and then rows. Okay, so if you like looking at data that way, Pandas is your friend. On the other hand, if you're sort of someone who deals with linear algebra, you might like NumPy more. Okay, so here's a situation where I import Pandas. And I do a similar thing that I do with NumPy. I do import Pandas as PD. So what that means is going on later in the script, I'll be looking for functions that start with PD. And let's see if we see any. Here's one. Right there. So this is a calculation of, looks like what I'm doing is I'm taking percent lead and percent lag 1, and I'm creating a 2-dimensional data structure, and I'm putting it into a Pandas data frame. So picture a spreadsheet. It's got 2 columns. It's got, on the left-hand side, it's got percent lead, and on the right-hand side, it's got percent lag. Actually, I switched that. On the left-hand side, it's got percent lag, and on the right-hand side, it's got percent lead. Right there. So what you could do then is you could use Pandas to see if there's a relationship between percent lag and percent lead. And this is the type of syntax that you use to do this. For example, give me a list of everything in the Pandas data frame where percent lag is less than 0. Okay, that would give you a set of data. Okay, and then I apply it, and then what I could do is I would go and get the corresponding percent leads, okay, and then I would calculate the average. Okay, so this would be something that maybe a caveman would do to try and predict the stock market. But it's actually kind of, in some ways, it is effective if you do it enough times, in my opinion. Okay, so that's an example of using Pandas. and creating features with pandas. Okay, so now we know how to create features using things with lists, Numpy, talib. Let's go into a discussion about this thing called scikit-learn, which is machine learning. I was talking to someone earlier who uses, anyone here use scikit-learn? Okay, we've got a few people. So here's how I see scikit-learn. It's this technology that allows you to create a black box. Okay, and in most simplest terms, you've got this black box, and it's got two buttons on it. Okay, one button is learn. So you press the learn button, and it says feed me. Okay, and what you feed it are Numpy arrays. Okay, but you have to be careful about how you craft these arrays, otherwise it's garbage in, garbage out. Okay, so what I do is I feed it Numpy arrays, which have these features that I've talked about. Okay, so that's the first button, is learn. Okay, then it's got a second button called what? Predict. Okay, so after it's learned, it can predict. Okay, so every day at 12:50, I go to my laptop and I press predict. Okay? When do I press learn? Well, at my leisure, okay? So let's talk a little bit about how this works. Okay. First, let's talk about this syntax here. From sklearn, import linear model. Okay, so we've seen import. Okay. This is new to us. So basically what this is this is sort of syntactic sugar that allows me to use this syntax like this. So when I call this function, I don't have a super long command line. It's just linear model.logistic regression. And this syntax here sort of makes that happen. The good thing is if you go through the scikit-learn tutorials and kind of treat it as a black box, it'll kind of hold your hand all through it. So I didn't actually figure this out. This is just sort of something that I followed. Okay. So remember this black box that I talked about like 2 minutes ago that's got the button that says learn? Okay. When you press learn, this is what happens. This gets called. Okay. This is the Numpy array full of features. Okay, so what would be a good feature? Well, maybe the current price divided by the 5-day moving average. Or another feature might be the previous day percent lag. That sort of thing. Typically what I do is I'll fill it up with like maybe 4 or 5 or 6 features, and then I'm done. Too many features is a bad thing. So I kind of like 2 or 3 or 4 features. Okay, okay, this here, okay, now I need to get into it. Well, we've got 2 minutes to describe classification, okay? Okay, so the way classification works, or the way it works in this situation, is I have this model, and this model is going to say, oh, the stock market is going to go up. It's going to classify up or down, okay? So for each observation, I have to give it an up or a down label. So that's the key word that you want to remember, is label. A synonym is category. Okay? So here you'll see the word label. So what this is, this label train, is a Numpy array full of 2 things, either up or down. The way scikit-learn works is it could be true or false, in which case then I would have a binary classifier. If I were, say, classifying weather, then I have like partly cloudy, sunny, rainy, that sort of thing. Oh, okay. Here is what an observation looks like. Okay, so this would be percent lag 1. So that's, in percentage terms, the lag over the last day, last 2 days, 4 days, 8 days. And then these are calculations from the Bollinger Bands. So I've got 6 features, and then this is what the data actually looks like when I look at this. Okay, so when I press the Learn button, I get a model. And so let me, a model, think of it as in terms of like this Python object that you can carry around. And it's actually got a name. It's called LR model. Okay, so that's where the model is created. Now I'm getting ready to push the predict button. Okay, and when I press the predict button, basically this is the syntax which gets sort of called, if you will. First thing I need to do is go and get the most recent price at 10 minutes to 1 California time and crank that through some Python and end up with a vector that looks like this. Okay. And then what I do is change it a little bit. So I have this. And I change that. And then the prediction shows up here. Okay. And the prediction is a value between 0 and 1. So the way it works is if it's like 0.6, that means that it's 60% confident that the stock market will go up the next day. If it's 0.4, it's 40% confident that the stock market will go up the next day, which is a negative prediction. Okay? So that's kind of what I do every day. Probably the next thing that I would want to do is try and sell this thing to you, right? So the way I would do that is I would show you how this thing behaved in previous time, using previous data. And that's sort of the idea behind this loop here. I'm going to end the talk here. I don't think there's enough time to go through it. It's 8:30. We kind of got to clear out of here probably within the next half hour. We need to mingle. There's job things. Does anyone want to go to the microphone and ask questions before I wrap it up? I guess not. Oh, yeah, we have the pie lady. Okay, have I made any money? Yes, I have. I've not gotten rich. One thing that I will say is I'm much more confident now than before. Before, when I saw the stock market move in certain directions, especially when it was going down, I had basically 2 voices going on in my head. Okay, one was, maybe I should get out of the way and pull all my money out. On the other hand, the other is, be bold, my man. It's going down. And what this has done is it's given me confidence to see, in retrospect, what has happened in the past when the stock market has done certain things. And the main thing I've learned is that the stock market does bounce, but it tends to bounce a little bit more when it goes down. Okay, the floor is bouncier than the ceiling. Okay, so what that means is when the stock market's going down like 3 or 4%, I have a little bit more confidence now than I did before. Another thing that I've learned is that, and this is actually something that you learn in statistics class, is systems that are made up of many, many things are more predictable than individual things. For example, in this room we have several hundred people. If I wanted to make a prediction about this room, like, I don't know, what would be the average weight gain for the room, I'd probably do better with the group than an individual person. Okay, so in my opinion, the S&P 500 is more predictable than LinkedIn. Okay, and that's something that that's an opinion that I've gathered by dealing with this problem and using Python. Question?
Hi. So I don't mean to sway away from your project, but one question I had with regards to scikit-learn
Yes.
is that it can compute large sets of data in quite a quick time. So I was just wondering if you could give us a brief description of what's happening under the hood, and is there something special that the whole scikit-learn package Is it using something special?
Is scikit-learn using something special? The answer is I like scikit-learn. Okay. I like the API. I like the demos. I like the fact that it's Python. It seems to fit well with Numpy. If I have a question about it, I go to Stack Overflow and I can usually get an answer in about 3 minutes. For logistic regression, it's pretty easy to use. I don't really have anything bad to say about scikit-learn. This particular problem, usually I'm dealing with the data that I starts with 16,000 observations. That's going back to 1950. Okay, and each year there's 252 observations. So in 10 years, that's 2,500. So I use about 6,000 or 7,000 observations, and scikit-learn can like slam dunk that easy. That data like fits in the RAM of my laptop. So for that particular problem, scikit-learn is ideal. Does that answer your question? Sort of. Okay. Next question.
Okay. Do you get to choose what you put in the scikit-learn? Like, if I like to use backpropagation, can I get it?
Okay. So, do I get to choose what I put into scikit-learn? For example, backpropagation. Can I use backpropagation? To me, for this demo, okay, scikit-learn is a black box. Under the hood has logistic regression. And how logistic regression works, for example, how they do the fit, they're probably using some kind of linear algebra type thing rather than backpropagation. If I were to do some kind of backpropagation technology related to machine learning, probably what I would use would not be scikit-learn. Probably what I would use is Theano. Theano, I'm learning it now. Maybe in a few months I'll come back and talk about that. It's a very elegant way to do backpropagation. Backpropagation, by the way, is one way to think of it is assume you're doing linear regression. You've got a scatter plot and you want to fit a line through the scatter plot. Okay, while you're moving this line around in the scatter plot, you're minimizing error. So eventually you get to the point where the line moving through the scatter plot is at a minimum error state. Okay, while you're going through this process of moving the line around, you want to do it in an optimal kind of a way. So what you do is you look at this, you look at how the error changes as you move the line, and you can be pretty smart about following this thing called a gradient so that each time you move the line, you're moving it in an optimal kind of a way. And that idea is related to backpropagation. Okay, it's kind of an advanced thing, but the main thing you need to know about backpropagation is it's a way to fit something like a line to something like a scatter plot. Does that answer your question?
Yeah, I'll talk to you later.
Okay. Yes. Microphone. Yeah.
Yeah, so I was wondering what you thought about TensorFlow and Theano, which you mentioned.
Okay, what do I think about TensorFlow and Theano? I'm wrestling with Theano now, trying to learn it. So I'm going through a process similar to this where I have this big, long list of questions. And I spend a lot of time on Google. And compared to Numpy and scikit-learn, okay, those are, in my book, are about like a 4 or 5 in difficulty. Theano is kind of up there like an 8 or a 9. It's for some reason, I'm not quite getting it. TensorFlow, I've spent maybe an hour with it, and I kind of get the same kind of vibe. I decided to go with Theano because there's these guys over at Hacker Dojo who have this thing called a Titan chip, which is this NVIDIA GPU that's like this big, giant thing. And I want to be their friend, okay? And they're using Theano. So that's why I'm learning Theano. And then they have access to this super expensive NVIDIA Titan GPU. And you know, once I know Theano, then I'll be able to go hang out with them.
Okay.
Next question.
So did you try to include other events
like 50 days moving average, sharp ratio?
Yeah, so he's talking about features. Okay, what are some of the different features that I can use to do the learning? I started doing this effort in 2008, okay? And I kind of went through this whole long thing of trying every feature under the sun. And what I learned was the most important feature is percent lag 1. Okay, percent lag 1 is the percentage change between yesterday and today. Now, there's other features that you can do. Like, for example, you can take a slow-moving average and a fast-moving average, and you can, like, divide them. Another thing you can do is you can take the faster-moving average and watch for when it crosses the slower-moving average, going this way or going that way. And what I found was percent lag 1 just wins big time. So that's, like, the most important feature. And it turns out you can actually figure that out using playing Numpy and a calculation called correlation. So the way correlation works is you look for, say, percent gain in one of the variables, and then there's a second variable that you kind of play with. So if you put percent lag 1 in as the first variable and percent lead, which is the thing that you want to, which I perceive as the dependent variable, percent lag 1 seems to have the largest, or it seems to have the greatest negative correlation. So percent lag 1 is, for some reason, seems to work for me. But on the other hand, you know, there might be other things that are sort of magical out there. All right, so I'm going to turn it over to Jeff, and Jeff is going to drive the meetup. And if you have any questions, send me email. Thanks.
Hello? Okay, great. Well, thanks a lot, Dan. That was really great. I learned some new stuff, and hopefully everyone else did too. I really appreciate that. Okay, so just go through a few things real quick, and then we'll let you guys go or just socialize. Hold the microphone in the thing. Okay, so volunteers. So I want to thank first, this is an incomplete, but the list I had from the emails I got of people who helped out tonight with greeting and with organizing things and all. So maybe a quick round of applause to those people. Thanks a lot. And we're always looking for volunteers. It's a great way to get involved, and you don't need any special experience. So being greeters, counting people, you can be a speaker. We're always looking for interesting topics. And one thing in particular, Glenn I had kind of volunteered to be this MC and kind of coordinate the meetup. And so kind of my backup is Glenn Jarvis, who's a really busy guy and, you know, has been doing it in the past. And thanks, Glenn, for getting this going again last month. He's there in the back. But it'd be great to have another person to help out as well. Because like if I'm out of town, so if you're interested, send me an email or come up afterwards or whatever. It'd be great to have at least one more person or more. We can kind of switch off, and it's really easy. Okay. And let's see. And of course, thanks to LinkedIn for hosting us. They did a great job. Maybe a quick round of applause for them. And Joshua said, please, well, maybe it's all gone now, but if there's any pizza left, please eat it, he said, because otherwise it just gets thrown out. Or take it with you. Yeah, okay. And one thing Glenn had reminded me, I guess, at the beginning of the talk when I said we don't have meetings on November and December, that's not quite true. They usually are kind of just moved to a different week. We don't have meetings on Thanksgiving Thursday, though. But so anyway, we'll have that later. And so these are some of the upcoming speakers that we have scheduled for the next few months. And so we'll get these going. And if you'd like to talk, let us know. And they should be very exciting. Okay. And And if you have a talk or something you're interested in or want to give a talk, let us know, and we'll see what we can do. And so finally, if anyone has, well, second to last thing, if anyone has any post-talk announcements, you can come up to the mic or come to this mic. I guess one for me, well, of course, there's the Pi Ladies. Don't forget Vicky. And one thing from me is I'm going to be starting a project with Internet of Things in Python 3. And if anyone's done stuff like that before, I'd love to talk to you and hear what you've done. So maybe I'll be somewhere around here. Okay, you want to?
Hi, my name is Shomnath Banerjee, and I'm the CTO of Lodge IQ. We just got funded. Lodge IQ is a play on words of lodging IQ. We help large hotel chains to forecast their guest arrivals and price their hotel rooms according to that. Now, the great news is we are building our company exactly on the same stack as Dan outlined. So thank you, Dan. That was outstanding. I'm immediately looking for people. So anybody who's interested in data science, data engineering, or full stack engineering, contact me. I need to build a 15-people team in Silicon Valley immediately. So we're very well funded. Go look up in the web, you'll find us. And so just go on to contact me after the talk. Thank you.
Can I give a pitch?
Sure.
Okay. Quick pitch. Hello again. I have a class that I invite you to. Unfortunately, it costs money. It's a data science time series class. Meets 10 times. Okay, so if you felt that I kind of rushed through tonight, well, you can come to 10 different Saturdays for 4 hours. That should put you to sleep. So it's kind of long. It's taught through, but it's in the morning, so maybe you'd be more awake than tonight. It's taught through the Santa Clara Adult Education. It's $400, time series data science. I'm the instructor.
Great.
Starting the first Saturday in March. 9 a.m. on Saturday.
Any other announcements?
Hi, I'm Wesley Chun. I'm a fixture in the Python community, but I had a public service announcement. For anybody who's interested in going to PyCon in Portland, I've been talking to the organizers, and they're saying that there's a very high probability they will be sold out by the beginning of March. So if you're interested in going to the conference, you need to register ASAP. All right, that's it.
Thanks. I think it's in June, right? The conference?
End of May, beginning of June.
Okay.
In Portland, just an hour and a half flight.
Okay. So last thing would be if anyone wants to offer a job. We already had one job offer. Or if you're looking for a job, this is a good time to introduce yourself. Go ahead.
Here? Hello?
Yeah.
Hi, my name is Semi. I come from a physics background and some computational math at Stanford. I recently quit my job in IT consulting because I wanted to do more data analytics. So I thought this would be a good chance to announce myself. I'm currently doing Kaggle competitions at home, but it would be nice to get paid. Thank you. Semi, S-E-M-I-H. Thank you.
Anyone else? Well, okay, please.
Hi, my name is Lisa Bang. I originally come from a biology background, but I just finished my master's in bioinformatics, mostly working in Python. Yeah, a lot of machine learning, like especially feature selection, random forest, things like that. Yeah, I'm looking for a position in data science because of my relocation back to the Bay Area. Is there anything else?
Great, thanks. Okay, well, thanks a lot, everyone, for coming. It was great having a almost full room. and hope to see you next month.